Hey everyone, welcome to your last two labs, Lab 8 and Lab 9. So Lab 8, this experiment is kind of a little bit more complicated because you have to do a lot of prep work beforehand by getting two small containers of milk, opening one of those containers 7 days before the experiment. Before this lab can even occur, this milk has to have been open for 7 days prior to you doing anything. I always say, just get a small container. A lot of times you can find them at the grocery store or even like at a gas station. So don't get a half gallon of milk or a gallon because you're going to kind of waste it if you do that. So if we go into Lab 8 about food safety, you've got your, kind of overview of, foodborne illnesses, kind of where they come from, what they can do, how does food become compromised. Definitely make sure you understand the difference between endotoxins and exotoxins. Food safety at home, like what can you do to prevent cross-contamination. Make sure you do your questions for each one of your explorations. Going into the experiment, so you need lettuce, fresh, unwashed lettuce. You're going to need to get that from the store. You need a cooking pot. You need two small containers of milk, which we kind of already talked about. And then for your Science Interactive supplies, you need that nutrient agar tube. Get your, test tube rack and all that, good stuff, your gloves, petri dishes. So you need two poured petri dishes. So down here, way at the bottom, it's talking about the milk. So open one container exactly 7 days prior and allow the second to remain closed until using the procedure. So when you open the container, you want to leave it open, but put it in the refrigerator. Don't leave it out, okay? That will not go well for anyone that is living with you or you just living by yourself. It's going to go bad, okay? So open the container, leave it open, put the milk back in the fridge, and then your second container, don't do anything with it, just leave it in the fridge, okay? Try and get containers that have the same expiration date and you buy them on the same day. Otherwise, you kind of mess with the variables of the experiment. So going into the actual experiment itself, part 1 is where you're going to use lettuce and agar plates. So you need two already poured agar plates, or if you're pouring them while you do it, that's fine too. You're going to wash your hands very thoroughly. Then you're going to take a permanent marker, divide that agar plate into half. One half you're going to label fresh milk and then milk opened. And then your second agar plate, you're going to do the same thing. You're going to put a line down the middle, and one side you're going to put lettuce washed and then lettuce unwashed. You're going to get a swab, kind of moisten it with distilled water, rub that moistened swab on the surface of the unwashed lettuce, and then rub that, swab all over the lettuce unwashed section of the agar. Then you're going to, get a new swab. You're going to take the lettuce, you're going to thoroughly wash it with soap and water, pat it dry, take that swab, moisten it, rub it on the washed lettuce, and then take that swab and rub it on the part of the agar plate where it says washed lettuce. All right. Then you're going to get a sterile swab, saturate it with the milk that has been open for 7 days. So just dip it in there, kind of swirl it around a little bit. Okay, rub that sample on the section of the plate that says milk opened. Okay, then you're going to get another swab. You're going to open that fresh container of milk, right? Dip the swab in there, rub it on the milk unopened side. Okay, and then you're going to let these agar plates incubate. So after they've incubated, you should have some growth that you're observing. If it doesn't grow at all, you need to repeat the experiment. So I know it says, get rid of, some of this stuff, but just wait and make sure you have some growth. Then you're going to you know, make your observations. You're going to count the number of different colonies in each section. You're going to record that in the data table, and then you're going to answer your questions down here. So if we look at the data table, you're going to have types of microbes is going to be like your best guess on what you think it is based on what you learned in the exploration. Okay, so types of microbes that might be in the fresh milk, the milk that's open, the lettuce that was washed. Oh, bless me, sorry. The lettuce that's unwashed, and then how many, you know, number of colonies there are. All right. Photo. Okay, you're gonna have all 4 plates lined up. You're just gonna take a picture of it, upload it here. Okay. Then you're gonna go to your evaluation, answer your questions, and you're good to go for your next lab. So this is done. Go back into where lab 9 is located. This one you're going to need some people to help you with. It can take up to 2 days to complete, but it just kind of depends on you know, circumstances that you have. So we're going to click on the link. You're going to look at different types of diseases, infectious, you know, kind of versus contagious, answer some questions, you know, how are diseases transmitted, incidents and vaccines. So essentially like, you know, how often does it occur, and when a vaccine is introduced, you know, what can happen over time. This section just talks about different kinds of vaccines, and then flu versus cold viruses. Okay, and each one of these, right, has questions to answer. I will say that this table is very important, so make sure you review it very carefully and understand like what is happening with each disease. For your experiment, you're gonna need assistance, probably at least like 7 different people. Now, can you do it without people? Yes, it just gets a lot more complicated if you're like doing it completely by yourself. It is possible, it's harder. You need your distilled water, you need a measuring spoon. For your lab kit supplies, you know, get your phenolphthalein solution, pipette. You need 8 plastic cups, and then you need some sodium hydroxide. It might be labeled NaOH on the tube. So for this first part, okay, you're basically interpreting this table down here. So it says, you know, you're looking at this. Determine the 6 diseases with the greatest reported incidence. So then you're going to list the disease name that has the greatest reported incidence in data table 1. So if we kind of look at this data table, right, what is the disease that has, you know, basically the most amount of cases, if for lack of a better word, and then you're going to put like how many cases, okay? And then you're going to do, you know, what's the second one? What's the third one? 4th, 5th, 6th, right? In data table 2, we're going to get there in just a second. Right, so you're copying the values, and then you're going to look at data table 2 and complete the missing information in the data table. So include the 6 diseases you identified as having the greatest prevalence. So this is the information that you're going to kind of put in here. You're going to put the name, how is it transmitted, what are the symptoms, how can it be prevented, and then what is the treatment. So if we look at data table 2, right, we've got common diseases, right, how is it transmitted, you know, is it a bacteria, is it a virus, what are the symptoms, how do you prevent it, you know, how do you treat it, is it curable? You don't need like paragraphs of information here. Like a sentence or 2 is just fine. All right. Then you're going to have questions to answer. All right. Then we're going to go to the modeling disease transmission. So essentially experiment 2. So you're going to get 8 of those 9 plastic cups. You're going to pour that bottle of sodium hydroxide solution into the first cup. This is going to be like kind of like a stand-in for like a disease-causing microorganism. So maybe like, you know, a flu virus. So in each of the 7 remaining cups, you're going to get that tablespoon and you're going to put 2 tablespoons of distilled water in each of those 7 cups. So you've got 1 cup that's got this 30 milliliters of sodium hydroxide, and then you've got 7 cups that have 2 tablespoons of distilled water. Somebody needs to rearrange those cups without anybody watching. That's why it's important to have, you know, somebody kind of help you with this. You're going to form a hypothesis about, you know, how many quote unquote people are going to have the disease at the end of the experiment. You're going to announce this, you know, kind of like this blurb to the assistants. And then people are going to start mixing the solutions. So it says right here, you know, like to mix them, you're going to carefully pour all the contents of your cup into another person's cup. And then the person that's got the, you know, the full cup, they're going to pour half of it back into your cup. So this is kind of like sharing drinks, right? And you're going to do that with a total of 3 people. Don't actually drink anything. You're just mixing them, right? And so then after all the solutions, you know, like after it's all done, right, you're going to set all those cups down and you're going to put 3 drops of phenolphthalein solution into each cup. This is an indicator. If the mixture turns pink, it means that somebody has tested positive for the disease. And so you're going to record data in data table 3 and you're going to calculate percentages. So if we kind of look at that data table, right, how many beverages did you start with? How many people at the beginning had the disease, right? Should be 0. And then how many people at the end had the disease, and then what is, you know, calculating that percentage, right? So essentially, right, like beverages impacted versus, you know, total beverages, you know, percentage versus people that, you know, had it versus people that didn't. As far as like panel 1, this is your broth culture results. So actually that, I don't believe that needs to be there. Yeah, because you didn't actually use the broth culture, so don't, I'm not sure, oh, that's a Science Interactive issue. Yeah, don't, I think what they mean is this is your hypothesis for, you know, how many people are going to be infected. I don't know why it says broth culture, but yeah, just hypothesize, okay, you know, this number of people are going to be infected at the end of the simulation. All right, so that's all you got to do here. And then write data table 3, I already showed you. So then once you've answered your questions at the bottom, make sure to do your evaluation. You know, that you've done your extension questions and that you've answered everything in this lab, and then you are done. And that is the final lab kit lab. So good job getting through all those. I know they can be difficult, but if you have any questions, you know, reach out and I'll be happy to help.